All right. Hello, everybody. Now that I remembered to hit record. Today we have Austin Pearson. He is a climatologist with the Midwestern Regional Climate Center in the Indiana State Climate Office. We're excited to have him here today talking about climate and what that looks like in Indiana. Yeah, as far as housekeeping goes, make sure you're on mute. If you have any questions, please put them in the chat and we'll get to them probably at the end for the sake of time. Um, I'm going to put on a short demographics poll. Again, this is completely voluntary, but it helps us know who we're reaching and who we still need to reach. So please feel free to fill that out. And then, yeah, I'm going to turn it over to Austin. So thanks.
Thank you, Jess. I'm Austin Pearson. I'm a climatologist with the Midwestern Regional Climate Center and with the Indiana State Climate Office. And many of you probably didn't even know that we had an Indiana State Climate Office, which is unfortunate, but we're still trying to get our names out there. We'll talk a little bit about some of the things that we do around the state, and a lot of what we do is climate monitoring and outreach. And so one of the things that we do, like today, is giving presentations for you all to understand a bit more about Indiana's climate and some of the scenarios that we have on the docket for the future potentially, and then just some ways that we can protect some of the plants that we're working with in Indiana. So the first thing I want to talk about will be the difference between weather and climate. And a long time ago, Mark Twain mentions, and I think several others have said this as well, so it can be accredited to several people. But Mark Twain, back 1835, 1910, was when he was alive, and that was before the dawn of computers, believe it or not. And so he knew that climate is what we expect and weather is what we get. So what does that mean? And so when we look at weather, we're looking at conditions of the atmosphere at a particular time and place. So we're referring to the current conditions at a particular location. So this is a graphic that was pulled from a couple of years ago at the Greater Kankakee Airport in Illinois. And so you can pull the information in from there. You get the air temperature 84 degrees. I wish it was 84 degrees right now, but we're certainly dealing with very, very nice conditions across the state today with 54 here in Kokomo area. But overall, I mean, you can get the humidity for a time frame, a certain time, and that would be the amount of moisture that's in the air. So the more water vapor that's in the air, the higher the humidity would be. And so when you're out in the summertime and you've got pretty close to 100% humidity, it's very sticky outside, and you don't really want to be out there for that time. Looking at the wind speed, it's another thing that we like to look at when we're talking about the weather. But these conditions are changing day to day, and most of these changes are tied to weather systems such as cold and warm fronts. And so we've had a few of those here recently where we've had some precipitation, especially in the month of January, where we had that cold Arctic outbreak across the area. We had some warm fronts come through, warm temperatures back up. So a lot of sporadic changes between the day-to-day weather are just tied to a lot of those cold fronts. And so looking at the climates, we're looking at longer term periods. So that would be typically 30-year averages or more. And we can get those for temperature, precipitation, growing degree days. And so growing degree days is just another way of assessing how plants could potentially grow given the temperatures that we're experiencing. It's another way of understanding the maturity levels that different crops are, like corn in the cornfield, understanding when they're going to get the black layer, when certain varieties are going to grow and produce fruit. So things like that we can get with climate normals. And so we're looking at 30-year averages, and this is January 1st to December 31st. This is our annual precipitation that averaged from 1991 to 2020. It's a new normal that came out recently. And right up in central Indiana, you see Howard County, you can get anywhere from 40 to 42.5 inches. If you're anywhere to the south, down near southern Indiana, you can get up to 50 inches of precipitation in a year. And I did want to include that this does include melted snowfall. So this would be the liquid water equivalent for any snowfall that ends up falling. And then when you get up closer to Lake Michigan, those precipitation values start to decrease and go down. So up there in northern Indiana, 37.5 to 40 inches. So quite the spread from north to south when you look at our normals. We also get normals. We can break them down into monthly timeframes. So when you're looking at uh, the monthly temperatures across, and these are normals, so this would be the 1991 to 2020 average temperatures for that particular time, and you can see that our warmest month of the year is that June to July timeframe, and so average normal highs in July are 83.7. And minimum temperatures at 62.5 degrees Fahrenheit. And if you average those two together, you get 73.1, which would be the mean temperature for that given time. And, recently, if you look at February, we've been experiencing highs in the 40s and 50s. And if you look at this chart, you can see that the average maximum high in February is 36.9 degrees. So we've been anywhere from 10 to 20 degrees above normal for some days throughout February. Even when we had that cold spell in January, you can see that the normal max temp is 32.5. We did have a couple of days where we had temperatures around that negative 10 degree mark. So it was pretty chilly across the area. But overall, when you look at the month, we ended up averaging right around normal for temperature. And that's just going back to looking at the beginning of the month versus the end of the month when we had warmer conditions compared to that one cold week that we've had back in January. And then looking at the precipitation. So this is all liquid content for precipitation. So if you're a CoCoRaHS observer, we'll talk a little bit about that. You melt the snow down in the wintertime and you get that liquid water content that was part of the snow. And all this gets added and averaged into the station normal. And so you can see time series wise across the state, or this is for Howard County, the average precipitation in June is about 5.21 inches. And so last June, we actually had a really dry June. We were way below normal on precipitation, and actually several of our months were below normal. And so when you hear a meteorologist on television say, well, we had such and such rainfall, and it was above normal for that particular month, we're just talking about that 30-year period of record that we're talking about. February, we traditionally get about 2.43 inches of precipitation during that time frame. We have not received that rain so far through February. We did have some snow last Friday that brought up to 3/10, and I know locally we had 3/10 of an inch of liquid water equivalent during that storm. But some stations down in southern Indiana got up to a half an inch of liquid water equivalent. But overall, still tracking below normal across the state for that time frame. Looking at last year as a whole, this is the accumulated precipitation January 1st to December 31st. You can see that we had anywhere from 32 inches of precipitation right here in central Indiana, stretching over to the Illinois state line, all the way down to Indiana, southern Indiana, where we had up to 48 inches of precipitation that had fallen. But as you look at the observed versus the difference, so the difference between observed and the climate normals, that gives us the difference and tells us how much above or below normal we were. And many of you realize that we were fairly dry across much of the year last year. And so you can see right in central Indiana, we were anywhere from 8 to 10 inches below normal for the entire year, which is a lot of drought impacts that we'd seen across the years, drought stress. Maybe if you're a horticulture enthusiast, maybe you had to water your lawns, water your gardens quite a bit more frequently as a result of that. And so I noticed several times where we would have dormant yards, which was nice because if you're like me, you like mowing the yard to get your time to yourself, per se. But when you get 1 to 2 inches a week of rain, and then you have to mow once, twice, 3 times a week. That gets a bit old after a while. Which I feel like once we got to September last year, I was definitely mowing more than I should have been during that time frame. But overall, drought impacts across the state pretty much lingered into the winter, and we'll talk a bit more about that here in a little bit. So many of you have probably heard about the El Nino Southern Oscillation. We like to call it ENSO for short. So anytime you see ENSO, that's what we're talking about. And so, what is ENSO? We're basically talking about the latitude, longitude coordinates just off of the western side of South America, where we're assessing temperature differences and trying to determine if they're above normal or below normal. Before this previous winter, we were in a triple dip La Nina where ocean conditions in that particular location were below normal. And so you have to be a half degree Celsius below normal for a La Nina. And then for an El Nino, which is what we are currently in and going to be phasing out of by mid growing season here, the temperatures are warmer than normal. So a half degree Celsius warmer than normal in that particular area. And what happens there is we have these atmospheric patterns that start to take shape based off of the warmness or coldness of the water in that region. So for the El Nino conditions that we've had, you can see here, typically of this pattern, especially during the wintertime, you get an amplified Pacific jet stream across the southern portion of the United States. And a lot of that is because of a low pressure system that likes to set up over the Pacific Ocean off of the western coast of the US. And so when you think of a low pressure system, you get uh, a counterclockwise motion, just like we would if we have a cold front or a storm system that's going to be moving across the United States. We get this kind of a flow that sets up where we get the warm air that's from the south and we draw that up to the north. And so as that flow across the United States is generally from west to east, especially during that time frame, we get that warm air that starts pushing over the northern side of the United States. And based off of that, some of the atmospheric pattern cuts off some of the wetness that happens. So we typically get drier conditions during an El Nino time frame. And so that is something that we deal with that. So this winter's pattern has been typically mild or fairly mild. We've had 1 or 2 instances of frozen soils. The first time that we had frozen soil is back in January timeframe. That second week of January in particular, we had soils that were frozen down to 10 or 11 inches, and it took a bit of time for those soils to thaw out. But this last week, especially over the weekend, we had soils freeze down to about 4 inches in certain spots. So that's 2 events that we've had where we've had frozen soils, and we've since warmed up and soils are no longer frozen during that time frame. So that oscillation back again, you get the La Nina condition. This is the pattern that we've had pretty much off and on for pretty much the previous 3 winters to this one. Whereas the difference you see with this is that you have a high pressure system that's blocking the overall flow of the Pacific jet stream. And so with this, you get a cyclonic or a clockwise rotation with that high pressure system. You get the cold air that's up to the north, and it starts to bring that down to the south. And so you get this variable polar jet stream that typically brings wetter and warmer conditions during that time frame, and that's something that we saw definitely over the past 3 winters before this last one. And so one thing that's been lacking during these El Ninos and La Ninas, at least the past 3 years, has not been a lot of snowfall. And so just some of those things that, whether this is going to be a continued trend into the future, especially with, climate change and what we'll talk about later with that as well. So the ENSO neutral winter pattern, this is just where you have the cold settle over the northern United States. You get your Pacific jet stream that pulls warm, wet conditions across the southern United States. But overall, that's what you would see in an ENSO neutral winter pattern. We haven't had one of these for a few years, but overall, we've had that warmer winters, just a lot dealing with the ENSO patterns. So where are we at currently? We have the El Nino Advisory, La Nina Watch. So we have warmer than normal conditions that are observed. The atmosphere is still showing that pattern that is similar to what we had seen with the flow pattern with the warmer and drier than normal conditions across the Indiana area. The sea surface temperatures are still above average in that rectangular box over the western coast of South America. Um, Atmospheric anomalies are also consistent with El Nino pattern, and they're still thinking that there would be a transition from El Nino to the ENSO neutral by likely April or June. So right at the beginning or mid growing season at that point in time, and then increasing odds of a La Nina developing in June, August, and then that could potentially last the through the winter. So a lot of things to take into consideration here. What's that going to mean for summer patterns? Still a lot that's unknown at this point in time, but I'll show you some Climate Prediction Center outlooks that we have available at our discretion towards the end of the presentation. So climate services, we've talked about weather, we've talked about climate. What do climate services do? And so we provide services that equip decision makers in climate sensitive sectors with better information to help global society adapt to climate variability and climate change. And so ultimately what we do is that we take data and then we take that data to provide information to stakeholders such as you all. And then what you guys do with that is hopefully make decisions to, properly maintain your horticulture plants, or if you're a farmer, planting decisions or different crop allocations and stuff like that with those types of things. So we're ultimately trying to make data accessible for you all to make decisions. And so there are three different areas that we like to look at that climate services exist. We are a bit different from weather forecast offices. A lot of us that are in the data services, we don't really forecast. I don't forecast. I'll talk about the outlook, but a lot of them are governmental outlooks that we provide. But a lot of our work comes with the data curation, and then providing those tools for people to view and incorporate into those decision processes. But at the federal level, we have the National Centers for Environmental Information, NCEI. That's through the National Oceanic and Atmospheric Administration, which is part of what our Regional Climate Center is part of. They also direct the National Weather Service. That's also part of NOAA. National Weather Service does have climate services within their entities, but a lot of what they do is forecasting and stuff like that. But they do a lot with National Weather Service co-op observers, which are long-term volunteer weather and precipitation, temperature precipitation observations. At the regional level, we do have the regional climate centers, and we'll talk a bit more about each of these individually. And then the state level, we have state climate offices, which are there to help us make state-based decisions. But when we look at the National Weather Service Cooperative Observer Program, this is federal data, and we're getting daily temperature maximum minimums. We can calculate the average temperature by just taking the average of maximum minimum, gives us our mean. We get precipitation, rain, snowfall, snow depth, but not every station actually measures snowfall or snow depth. And so there's a lot of spatial gaps, especially when we're looking at snowfall data across the state. Now here at on the map, this is from our Climate data portal that I'll talk about here in a little bit. The blue dots are the actively observing stations, and the gray ones are ones that are no longer in observation. And a lot of times, these are all stations where we have a thermometer and a rain gauge and sometimes snowboards. And observers go out every morning between 6 and 7 a.m. and take observations. Um, every holiday, uh, whether they're on vacation, so on and so forth, someone is there to make a measurement at those sites. Now, that takes a human observer, and sometimes we get issues where people, transcribe data into the weather coder in a like not correctly, and so they're quality controlled through National Weather Service. They go back and make sure and verify whether that was indeed a true measurement or if there was a mistake in the observation. And then we can go back and follow up with the observer and get that corrected in the meantime. But the gray stations are, again, the ones where they're no longer active. And one of the things that we're having is an issue with people retiring, moving on, and in some cases passing on. And so we're starting to lose some of these sites in the longer periods of record just because of that not ability to maintain observers through that potential site. And then looking at the other federal observations, we have the FAA. And the FAA is through the Federal Aviation Administration. So this is an automated daily source. And automated, we get hourly and daily data from these sites. A lot of these stations came online about that 1948 timeframe. And we have variables that are temperature, precipitation, similar to the National Weather Service co-op program. But in addition to that, we get humidity, we get addition of winds. And keep in mind, when we're talking about winds at these sites, we're talking about winds that are at about 30 feet in the 30 feet in the air. So not exactly representative of what's going on at the ground. We get pressure with that. Back in January, before that cold outbreak, we actually broke the lowest pressure ever recorded in January at the Indianapolis International Airport. And then we also get cloud height. If you look at January, it was one of the cloudiest Januaries on record. And in fact, it was the fourth cloudiest January on record. So if you felt the blues, the winter blues in January, I definitely felt it. And it was overcast. And we even had some issues with our weather stations actually being able to keep up with some of the light and battery power just because of the lack of light. Now, these stations primarily care about aviation. They don't really apply very well to agriculture, horticultural observations. So I'll talk a bit about the Mesonet station that or Mesonet network that we provide across the state here in a few slides. From the Regional Climate Services standpoint, so the Midwestern Regional Climate Center used to be at the Illinois, and we actually got that back here in 2021 at Purdue. And so we provide high quality climate data derived from derived information and data summaries for the region. So we monitor, assess regional climate conditions and their impact. We also focus on agriculture and water quality issues at our site, especially since we have the Great Lakes in the area, as well as overwhelming proportion of agriculture within our region in the Midwest compared to the rest of the United States. We also do applied research on climate related issues and problems. And then we've also worked with key stakeholders like the National Weather Service. We also work with the ag industry. We've got a stakeholder workshop that'll be in St. Louis with some of our stakeholders in May to just kind of talk about what data products and tools are needed to help things, to help you all make decisions. And so if you go to the Midwestern Regional Climate Center, I know Courtney sent out the link to our website here yesterday. But if you go to our site, our main bread and butter that we get are data products, and you can go pull customized data and maps and stuff is this Climate. So you can go and get Kokomo 3 West Southwest data, National Weather Service co-op station data from that particular location in Climate, and it's absolutely free for you all to play with. We also have static maps that update daily that you can go to Midwest Climate Watch and get those. I'll talk a bit about the National Climate Assessment that was just released last fall in the November timeframe. and different products that are on our website like that. One of the things that we have here with the Midwestern Regional Climate Centers, we also have the ability to create GIS or maps overlaying snowfall data and other types of data on our website. So here on the left is the updated climatological normal for snowfall in a given year for Indiana and other states across the Midwest. Obviously, we don't receive the lake effect snow that the Upper Peninsula of Michigan receives, where they get over 96 inches of snowfall a year. Looking down at our area, we typically get anywhere from 18 to 24 in central Indiana, 18 to 24 inches of snowfall. Now, these last 3 winters, we haven't even gotten anywhere close to that. And so been relatively low on the snowfall standpoint. And looking at the right map, this is the estimated number of inches of snow accumulated. This is through the 18th at 7 a.m. And so you can see that most of the state has seen between 6 to 8 inches up in north central. They received one lake effect event up in northern Indiana that dominates the snowfall accumulation back when we had that Arctic outbreak in January. They had several instances, especially up in LaPorte County, with snow above 21 inches during that storm. But widespread 8 to 12 inches observed for most folks across central Indiana. And then when you start getting down into southern Indiana along the Indiana-Kentucky border, 1 to 2 to even up to 3 inches of snowfall during that time. Now, winter isn't over, but I will caution that our chances of the snow, especially going into March, once we get snow in March, it doesn't really stick around for very long. So typically melts off fairly quickly. This winter, outside of the snow that we had back in January and the extreme cold that we had in January, and this little cold spell that we had this weekend, it's been overall mild. And a lot of that is thanks to the El Nino conditions across the Pacific Ocean. There's other oscillations that play into that, but the Arctic oscillation is what kind of drove the cold outbreak in January, and then the unsettled pattern where we got some more rain. And so that was one of the patterns that kind of contributed to that, but mild conditions for most of the Midwest. And when you start looking at some of these stations up at the Minnesota area, there's some stations in Ohio that have record mild winters. And this is based off of our accumulated winter season severity index at the Midwestern Regional Climate Center. And so what I did was I pulled a map for a accumulation time series for Indianapolis, and you can see most of the winter for up until that Arctic outbreak we had in January, we were teetering right along the lines of a near a record mild winter. And then we had rapid accumulation within the index, almost got us to the moderate, and then it warmed up again and pretty much stayed warm until this last cold snap that we had this weekend, and we had a little bit of accumulation. Based on the outlook, I don't see this accumulating a whole lot more between now and the end of the winter, based on the Climate Prediction Center outlooks. But ultimately, we'll have to see how things are. But certainly, there for a while, I thought we were going to get pretty close to that near record mild winter across the state. One of the other products that we have at the Midwestern Regional Climate Center is the freeze date tool. So you can go hover over a particular county in Indiana if you want. I went ahead and pulled it for Howard County. And so when you look at this, you can get trend and last spring freeze dates. And so what this is basically telling us over time is that these trend lines are, granted, you can see a lot of dots that are everywhere. These are all the observations from 1950 to 2021. And you can see that overall, there isn't a trend for where the last spring freeze is getting earlier in the year. And so this is true for various temperature thresholds. across that. So you can see the 20 degree, the 25, 28, 30, 32, 35, 36 across the top. And ultimately what we're seeing is that last spring freeze is getting earlier in the year. Now, keep in mind, we do have freeze events that happen in May. And so that's something to take into consideration, especially if we get an early start. So bringing tomatoes, horticultural crops outside, you know, be very careful with that. Just because I say that the trend is getting earlier in the year doesn't mean we can't have a later spring freeze. Trends in first fall freeze. You can see this with this graph for Howard County. And ultimately what we're seeing with that is with that trend line pointing down, with the dates increasing here on this axis, the first fall freeze dates are actually getting later in the year. And so when we're seeing that overall, you can see a lot of variability across these dates. So this green bar represents the begin and end dates of each growing season, just where we had that 32-degree temperature using that threshold. The average start date is April 26th. The average end date is October 13th. Ever so slightly, that window of growing season is increasing. And so if it continues to increase, is there potential to start planting earlier with certain crops? Are there different species, varieties that we could bring in so that are further south that we could bring in Indiana? The jury's still out on that, but certainly something to keep an eye on, but certainly a lot of up and down and variability across growing seasons. One of the other products that was just recently released through the Midwestern Regional Climate Center was the chilling hours tool. And so what you can do with this is go into that and select a station in the Midwest and see how many chilling hours have accumulated. And so what a chilling hour is, it's another way of assessing whether or not a perennial crop has had enough chilling hours to be able to produce a decent amount of fruit for the year. So a lot of times we use temperature thresholds of 32 to 45 degrees. And basically what we do off of that is we count the number of hours that have happened that have been between those temperature thresholds. And so the more chilling hours that accumulate, the better off plants are. And you can see a lot of our trees and stuff we're putting buds on in February. And so they're starting to wake up a little bit, but I think we've had more than adequate accumulations across Indiana this winter with over 1,000 chilling hours accumulated. And when we look at how that compares to normal, we're anywhere from 200 to 400 and even some spots over 600 units above normal for the chilling hours based on this time of year. So one of those things to keep an eye on. I think we've had enough. The thing is like if these chilling hours have accumulated enough and then we do break dormancy early, which given the outlook may be a possibility, we might have to be a little bit more protective of our crops, especially our perennial crops that try to break that dormancy this spring. So frost potential is still there all the way through May. So it may be kind of a difficult spring, especially for the fruit crop industry. Looking at soil temperature climatology, we also have one of those. We look at when temperatures warm above 50 degrees, which is a lot of times where row crop agriculture will go out and plant, is when you hit that 50-degree threshold. A lot of that also can convey into a horticulture or gardening threshold as well. But overall, for central Indiana, we would hit that 50-degree threshold on April 11th or between April 11th and April 20th, and that is on average. And so we also have those that are for the fall, where you can see where we would hit that as well. State climate offices, they're oftentimes partnered with universities and state government agencies. There's really not a lot of funding. Some states have it in the state legislator line item where they get funded. Indiana does not. So all of our funding indirectly comes from the state government, but is allotted through the Department of Agronomy, and it's really not a lot to sustain full-time folks. So across the Indiana State Climate Office, we have one full-time person essentially, and that's shared amongst 5 people. And so there's a lot of people doing the work of one person, and so it's difficult to dedicate the time to the state climate office that it really deserves. But a lot of our roles deal with outreach, articles, interviews with media. So we do a lot of presentations for extension folks, and then also write articles for like Facts for Fancy Fruit, Pest Crop, all the extension newsletters. We manage the COCORAS program, so the Community Collaborative for Rain, Hail, and Snow network across the state. And so we co-coordinate that with the Indianapolis National Weather Service office. And then we also do the Mesonet program. And so when we look at the COCORAS Community Collaborative Rain, Hail, and Snow Network, these are volunteer observers. And so many of you may be observers and report every day. And if you are, I just want to thank you for everything that you do, and go out and observe those precipitation. We've got Precipitation Absurdity 2024 coming up, and it's basically our marketing blitz to get people to volunteer for the COCORAS program. Used to be known March Madness, but with copyrights and stuff like that, we felt that it was probably time to change that, and kind of steer away from that March Madness. And here we are in March, and Purdue's starting to lose in basketball again. So we're par on course every year. So that's something that we deal with, us disgruntled Purdue fans. We do have these COCORAS Community Club. These are the sites across the state. And so what these do, they help us get precipitation data, and fill in the gaps between a lot of those COCORAS, or the co-op observer things. And so these data get fed to their data platform. The National Weather Service utilizes those, and they put those in for forecast verification to make sure people are getting those. They're also being incorporated into weather models, and so on and so forth, as far as forecast verification. And these data get reported daily, and help us make decisions based off of that. And one of those things that we make decisions off of these is coordinating data into the National U.S. Drought Monitor. And a lot of that information goes in, and then we provide recommendations weekly, and then the National Weather Service, or the national authors, either accept or reject what we had recommended for the state. Most of the time, they typically accept our recommendation. The other thing that we have too is the Purdue Mesonet. And so the Mesonet is a mesoscale network of high quality research grade stations. What we're trying to do is provide local weather observations for you all to make informed decisions based off of. And we've got 14 stations across the state. Our 15th station is going to be installed in Posey County here by the end of March. We take air temperature at 3 different heights for monitoring the temperatures at different altitudes or different levels. So 0.5 meter, 1.5 meters, and 3 meters. We also look at soil temperature, solar radiation, the humidity, so how much moisture is in the air, and we've got wind speed and direction. We do receive national funding for this, but it's not enough to sustain the network. And we're looking to expand the network across the entire state. And so our goal within the next 10 years is have 1 station per county. We want to prioritize agricultural areas and fill in the gaps. So we need to identify communities in need, and then adding value for folks to be able to do that. So we've got snow monitoring at one of our stations in Lafayette. We're also in the process of installing a camera and migrating to 10-meter towers. And our goal is to have something available for everyone across the state within the next 10 years. So if you go to our platform right now, you can get a map of data, and this is within the nearest half hour. So we're at 30-minute data right now. We plan to go more to a hourly, or not hourly, but 5-minute data in the future. This is the drought monitor. This is as bad as, this is the worst it got to in December. And then improvements throughout the winter. And so this is what the current map is showing across the states right now. So abnormally dry conditions still lingering. And so tiles have stopped flowing across much of the state for at least the past few weeks. Just something to keep an eye on. One of the things I do want to pull and draw attention to is that Indiana has warmed since the beginning of weather records since 1895 in the state. So it's increased by 1.5 or degrees Fahrenheit since 1895. And so that trend has continued to increase. So longer frost-free season, fewer cold days. We've had significantly warmer temperatures. December or last year was the fourth warmest Indiana temperature, but most of the warming has been in our overnight temperatures and something that we've been dealing with. As a result of these warming temperatures, many of you have probably seen the new plant hardiness zone maps. And so the left is the 2012 plant hardiness zone. The right is on the most recent one. And so the blue would be category 5B. Most of the state is now in the 6A and 6B, which is quite a significant migration of warmer weather northward. And so what this basically is doing is looking at that average annual extreme minimum temperatures looking over the last 30 years. And so that average annual extreme for central Indiana in 6A, we do have some instances where we get to -5, -10, which is what we hit back in January. And so one of those things that, we can see with these maps, and this ultimately decides what we can and can't grow in the state. So will this continue? And I think some of the models and stuff are suggesting this to continue warming. The other thing that we've been seeing is that Indiana gets about 6.13 inches more rainfall today per year based on 1895. Now, granted, the last couple of years we've been a bit drier compared to that, but the overall trends, and you see a lot of variability about that. But when you look at looking at statistics, the overall trend is for a wetter Indiana climate over the past several years. And so with that, we've seen more rain falling and more intense downpours. And so one thing that we've definitely seen throughout the summertime is that we get these 3 or 4 week gaps in precipitation, and then we get all of it at once. And then you also saw, devastating news down south in Kentucky, where some locations got more than 10 inches of rain and washed out homes across next to streams and rivers and fatalities and stuff associated with that. We've seen the 42% increase in the amount of rain falling and heavy downpours, and that's based off the Indiana Climate Change Impacts Assessment. Additionally, with that, we've seen significantly rising stream flows based on information in the Indiana Climate Change Impacts Assessment. Other things that we've seen is that the climate is changing. Humans are definitely a part of that activity. There's a lot of natural factors that go in with that. But the rate of warming, a lot is just how we're interacting with the environment. So the carbon dioxide and greenhouse gases have continued to increase. And with that, the global average temperature has increased as a response. And I know last year was tracking to be warmest ever global temperature on record. And a lot of the warming has increased over the US, and it's actually increasing higher than the global average based off of that. So we've seen more frequent heat waves. Last year and a couple of years ago, we had a heat wave with heat indices above 100 in May. And folks up in Chicago, there was a retirement facility or a nursing home that had their heat still on and had some people die from heat exhaustion. So something that we're going to have to be more flexible on changing those types of mitigation, or working with making decisions a bit better with weather conditions. More extreme rainfall has fallen east of the Rockies, and hurricanes have been more intense, and they've also caused higher storm surges. Many of you probably remember the wildfires in California, but also the ones in Canada that impacted the air quality here a lot last June, and it was pretty unbearable for times. But one of the things that the report says is that the more frequent the planet warms, the greater the impacts. And some of the impacts we just don't fully comprehend that can happen. But overall, I mean, looking at precipitation, we're comparing two different periods of record, 2002 to 2021, and comparing that to early periods of record, 1901 to 1960. And overall, annual temperature is increased by 1.5 to as much as 2 degrees and maybe more in some spots across the state. We also see those changes carrying through into wintertime. And precipitation has been 5 to 15% more across the annual precipitation and winter precipitation during those time frames. And another thing that we can see with that is that the summer temperature is actually cooled in some spots in Indiana, but the overnight temperatures have been the ones that have been increasing essentially. And so you can see that with increased summer precipitation as well. So we've also seen a decrease recently, looking at those two periods that I talked about, the most recent compared to early period of record. We've seen less frequent hot days. We've also seen a decrease in the number of cold days from that time frame. And we've seen an increase in warm nights based on those data. One of the other things that we see is that the top heaviest 1% of days, or the top total precipitation on heaviest 1% of days, is that we're seeing more events where we see 1 or 2 inches of precipitation at a given time. And so we're seeing more of those events that are happening, and also increasing the amount of volume of water that comes with that. We also see projected changes in hot and cold extremes at 2 degrees C of global warming. We see an increase in hot days, so days in number of greater than or equal to 95 degrees. So heat stress is going to be something that's going to be of concern. And then we see a decrease in the number of days below freezing. Also warmer nights. This can be something that could impact us with transpiration on crops, and just one of those things that we have to consider. I know I'm running short on time here with what we have, but I did want to draw your attention to the past plant heat zone. This is the plant hardiness zone. We plan on being in zone 7 to 8, just based off of climate projections, based off of the Indiana Climate Change Impacts Assessment. So continued further migration northward of the warmer temperatures, less cold temperatures per the day. And we do start to see some of that seasonal variability in precipitation as well. So overall, I did say we see increased precipitation for winter and spring, but an overall decrease in precipitation in summer and fall. And so more onset flash drought, rapid onset of drought conditions that can impact that as well. So with that, I did have some information on impacts and what you can do, but for the sake of time, I'm going to pause there and kind of jump into the outlook for this spring. Looking at the 7-day quantitative precipitation forecast, this is between now and the 28th. So the end of we have a leap year this year, so we do have the 29 days this month. But through the end of the month, we can get in the southern part of the state 1.5 inches to some spots up to 2.5 inches of rain, and a lot of that's going to fall Thursday, so overnight tonight into tomorrow. With that, we could see up to 1.5 inches of precipitation in north central Indiana, and less the further northwest you go across the state. The bigger picture, though, is that the mild winter looks to continue, and meteorological winter stops at the end of February. Meteorological spring begins in March. That does not mean that we can't get snow in March. As many of you all know, we do get snow in March from time to time. But we have elevated chances for above normal temperatures through that last week of March, or last week of February into the first week of March, with above normal chances of elevated precipitation amounts. And then the 8 to 14 days, so this would be getting us further into that first week of March with elevated chances of above normal temperatures and above normal precipitation. Now, keep in mind, it doesn't tell us how much above normal. It just is giving us a signal of how if we have those above normal conditions within the models agreeing with each other. And so if they are agreeing with each other, the confidence gets increased. And that's one of those things that we see with that. Drawing your attention back to the El Nino, we're still following that warmer than normal pattern based off of the El Nino winter pattern there. But when we start looking at March as a whole, the northern side of the state sees elevated chances for above normal temperatures with equal chances down in the from Indianapolis southward. So that's just another way that there's just not a lot of agreement amongst the models of what's going to happen with that. And the same goes for precipitation. So another way of saying we don't really know exactly what's going to happen at this point in time. But we've been stuck in this warmer than normal pattern, and I would expect that there's probably a good chance that we would see that normal than above normal temperature pattern continuing. So the season temperature outlook, this is March, April, May. Elevated chances for above normal temperatures and elevated chances for above normal precipitation. So this doesn't mean that we can't have a few days of cold snaps that come into play. Pay attention to your forecasters and make your decisions based off of what they're saying and kind of go from there. Again, probability is increasing for transitioning to La Nina. So the colder than normal conditions for that Pacific Ocean temperature. It's just one of those things that we have. And then the Groundhog Day was on February 2nd. Punxsutawney Phil predicted a early spring. And so just looking back over the past 10 years, Punxsutawney Phil has gotten it right 30% of the time. So that nods. He's not very good at his job, for one, which most of you all are like, well, meteorologists get paid to be wrong anyways. But I know, I get it. I get that stuff all the time. But overall, I think he may be onto something this year, given the INSO conditions and just this pattern that we've just not been able to break. So that's something that we're considering and keeping an eye on for the spring. I want to appreciate everyone's time. Thank you for joining today. And I will go through and start talking about some of your questions.
All awesome. Right. Thank you so much. Yeah. So some questions in the chat that want to get through. Jeff just posted a link to the follow-up program survey. So this will also be included in the email. So if anyone has time and wants to share feedback on this program. Yeah, as far as some questions that came up, for El Nino and La Nina, what would be the trigger for causing the water to warm up that way?
Yeah, so a lot of it has to do with the atmospheric conditions at that particular location, and then so if you get a lot of ambient sunshine, warming of waters during that location. There's also ocean current cycles that allow the warmer water to come up from lower. And then also colder water to sink down as a result of some of that. So a lot of that kind of goes into play. We've got buoys and satellite data that monitor that. That's about the gist of what happens with that. I do have a direct message from somebody here about the weather station at Cumberland Community Garden in West Lafayette. The FAA stations that are there, those are at the airport. So the West Lafayette one will be at the Purdue University Airport. You can get that data from the Midwestern Regional Climate Center Climates, and I'd be happy to meet with you and show you through that if you want. My contact information is on the slide. You can get that through there and get it from that. I'm not sure of the Cumberland Community Garden. I don't know if that is that may be a Kokoros station, which does not get reported to the FAA, but it does get reported back to the National Weather Service. And so one of those things that I can show you how to access those data as well. Catherine says to call it March Mudness. I love that. I'll have to send that back to the Kokoros observers, but they went for precipitation absurdity for 2024. Um, so Debbie asks why night temperatures are higher. That's an excellent question, especially during the growing season. We've seen some of those warmer night temperatures. If you think about a traditional atmospheric profile and the radiation that comes in, if you don't have clouds, a lot of that radiation entraps, a lot of that radiation gets re-emitted back to space. And so with warming temperatures, we get more water vapor in the air. And with that more water vapor, we get more clouds that develop. And so clouds like to insulate the atmosphere. And it's like putting a blanket over the land. And so that radiation that gets re-emitted back to the atmosphere gets trapped by the clouds and then reflected back down to the ground. And so that is what some of the warming during those nighttime temperatures that we're seeing with that. So we're keeping those there. The other thing that you notice that when we don't have clouds in the atmosphere, it usually gets fairly cold, and that you'll see frost develop. And especially at this time of the year, we just didn't have those clouds to keep some of that heat into the air. Says current conditions might control citrus. Well, Jessica had the question about the citrus outdoors. I don't know. We'll definitely have to see. Again, that's a few years from now. We'll just have to kind of see how things migrate, and we'll get a new set of plant hardiness zones as time goes. But based on models, at the medium and high emission scenarios, zone 7 to 8 certainly looks possible here in central Indiana. Yeah, I can include the slides for later. And so we can definitely have that. And if you have questions about things in follow-up emails, I'm certainly happy to answer that as well. Most of everything else that we see with these are thanking me for presenting. One from Matthias about cloud seeding.
That was the one I was gonna.
Yeah, so I don't really know a lot about cloud seeding, to be honest with you. I know that they've had some instances where they've tried to do some cloud seeding for making it rain in certain places, and I don't really know a whole lot about it, and I can't really provide a good comment on that, Matthias. Says, in your opinion, do you think climate change is the Earth going through its normal cycles over time, and Earth has had cooler, warmer periods as there has been climatic data showing warmer temperatures before the industrial age, vehicle pollution? I think there are natural cycles that we have to deal with, but the rate at which the temperatures have increased, especially over the last 50 to 60 years since the industrial age, what a lot of scientists are in agreement in that things are really human driven. Now, keep in mind, if you have a volcanic eruption or something like that, that's a huge natural event that can cause cooling effects. And so you can actually see some cooling in the 1980s timeframe, especially when you had the Mount St. Helens eruption. And so some of those things that go in there, natural cycles do play a role, but a lot of it, we're part of that. We're part of that issue where the climate has been increased and definitely increasing the amount of carbon dioxide and greenhouse gases in the atmosphere is a driver for warming. And so that's something that we see with there.
And then Kirk asked, are there regions or areas in the US that are changing quicker than we are?
Yeah, so the drying out in the West is changing quite a bit faster. So droughts in the West, I would say that we've been changing fairly quickly with the amount of precipitation that we've had. I'd have to go back and look at specific areas and comparing the rate at which things are changing. But I would assume that they're all pretty well on par with what we're experiencing.
Well, there's a little break. We can't not mention that Austin. It's always good to have you back in the extension group. After how many years has it been since you've been in Tipton?
Yeah, so I left extension full time the fall of 21. And then so I was kind of working part-time with the Midwestern Regional Climate Center and the Indiana State Climate Office um, in that fall, and then I transitioned to full-time in that spring of 22. So it's been a couple of years, and I spent 6 years in Tipton. So certainly a product of extension, and will always remember my fun times there.
We appreciate you speaking on today's topic. That's for sure.
Thank you, everybody. I think we're past time here. And if you have questions, feel free to follow up, and I'll be happy to get back with you.
Yeah. All right. Thanks, Austin. I'll go ahead and stop the recording.